Good afternoon, children. So, today we are going to start with a new lesson, rotation and revolution. So, the variety of life on Earth depends to a great extent on the spherical shape of the Earth. So, due to the spherical shape of the Earth, uh, the angle at which the sunlight strikes the Earth's surface is different, and at the same time, because of the spherical shape, uh, the amount of heat received is different in different parts of the Earth's surface. For example, in the equatorial areas, the rays of the sun are vertical, but as we move towards the poles, the rays become slanting. So the amount of heat received in different parts of the Earth varies greatly, not only with the latitude, but also with the time of the year. Time of the year meaning like when it is winter, that time the angle at which the sun's rays strike, for example, the northern hemisphere, when we are experiencing winter, you must have seen that if you stand out in the sun, you feel comfortable because during that time the angle of the sun's rays are not vertical. But during the summers, what happens is, say for example, June, May, we can't even think of standing out in the sun because during that time the rays of the sun are direct. So the daily movement of the sun's path across the sky, the changing length of day and night, the annual cycle of seasons provide the fundamental controls for air temperature, wind, ocean currents, and precipitation. So all of these make up the Earth's climate. So there are two primary motions of the Earth, that is rotation and revolution. Rotation is the turning of the Earth on its axis from west to east, the spinning of the Earth on its axis, whereas revolution is the movement of the Earth around the Sun. So the rotation and revolution of the spherical Earth on its inclined axis is responsible for variation in the amount of insolation or heat received in different parts of the Earth, about which we'll be studying later. Okay, children. So we all know that rotation is the spinning of the Earth on its axis from west to east once in 24 hours. So you can see the direction of rotation in this diagram. The axis is an imaginary line passing through the center of the Earth. So the two endpoints through which the axis passes are known as the North Pole and the South Pole. So the Earth is believed to be rotating on this imaginary line called the axis. Now children, let us understand the diagram of the inclined axis. Later on, I will be teaching you how to draw the diagram also. So what happens is that the plane in which, or the plane along which the Earth revolves around the Sun is called the orbital plane. So the Earth's axis is not at right angle to the plane of the Earth's orbit. The axis is inclined at an angle of 66.5 degree to the orbital plane, or the Earth's axis is inclined at an angle of 23.5 degree from the vertical. So in this diagram, children, if you see, when we draw a perpendicular line to the orbital plane, with that, the Earth's axis makes an angle of 23.5 degree. And with the Earth's orbital plane, it makes an angle of 66.5 degree. So if the axis was not inclined, every place on earth would have 12 hours of day and 12 hours of night throughout the year, and there would be no seasons. Due to the spherical shape of the Earth, the speed of rotation decreases both to the north and south of the equator. So as you can see in this diagram, the speed of Earth's rotation is maximum at the equator, and it goes on decreasing polewards, and at the poles it becomes zero, negligible. Alright, so the speed of Earth's rotation is maximum at the equator while it is slowest at the pole. As the radius of the equator is greater than the radius of the poles, So to cover one rotation within 24 hours, the equator must rotate faster. So that is why the speed is much more the highest at the equator, and as we move polewards, the speed goes on decreasing.